Okay, so if something is a function, then no x values repeat. Okay, so if you guys would please write that down. If you have a graph, the way you determine whether or not the graph is a function is you do the vertical line test. Okay, so everybody grab your pencil and I want you to draw a line right there. Okay, that line hits the graph twice. So everybody in the room tell me, is it a function? No, it's not. If it hits it more than once, then the answer is no. So just go ahead and write no and then box it or highlight it. Now I want to talk about this problem for just one more minute, okay? I want you to put a dot right here at that ordered pair and put a dot right there at that ordered pair. So those ordered pairs are -1, 3, and the other one is -1, -3. And remember, if something's a function, the x values can't repeat. Well, do you see how it's hit it twice? The x values are repeating, so that's why it works. So those are the same, so it's not a function. Okay. Everybody look at question B. Make sure you don't go ahead of me. Okay. Everybody look at question B. Draw a vertical line right there. So kind of off to the end. That graph is a cubic. Do the ends of the cubics, you guys, ever go completely vertical? Yes or no? No, there's always a slant to it. So will that red line, even if I moved it further to the right, would it hit the graph more than once? No. Is it a function? Everybody tell me. Yes, it is. Okay. Everybody look at question C and just kind of shout out the answer. What is it? The answer is no, because if I drew a line right there or many other places, it hits twice. So the answer is no. Okay. Very simple. Okay. Everybody, excuse me, everybody look right here, okay? So just please look forward, don't write, pay 100% attention right here. If I'm explaining something here and you're 2 steps ahead, you're not listening to me, and that's when problems arise, okay? So just stick right with me and we'll all be good. Okay, just kind of look forward for a second. Here is the y-axis right there, okay? There's the y-axis. If I took half that graph and I put wet paint over there on the yellow, and then I folded it across that y-axis, that wet paint would come over and it'd be right there on the green part, and it lies right on top of it, so that's symmetric across the y. Okay, let's come over to this one right here. Symmetric across the x. So look guys, here's your x-axis. Half the graph is wet paint. Take that and fold it across the x-axis, and it lies perfectly on the other half. That's symmetric across the y-axis, x-axis. Now look at this one right here, symmetric across the origin. So this one's a little bit tougher to understand. I want you to write down right here, reflect x and reflect y. Okay, so everybody watch, just kind of kick back and watch. Look right here, here's my x-axis. Take half the graph and make it wet paint. Fold it across the x-axis. Where does it go? It goes down there. It's not reflected across the x-axis because the other half of the graph is not where I put that pink highlighter, right? But if I then take that pink highlighter and then fold it across the y, it lies on the other side, hits the other graph perfectly. That's reflected across the origin, okay? Now, I want to show you one more thing. Look right here, guys. So if I reflected across the y first, on the one I just did, I reflected across the x first, right? So if I reflected across the y first, that yellow comes over there to the pink. And then if I take that pink and then fold it across the x, then it lies on top of the other half. So it doesn't matter if you go x and then y or y and then x, it all ends up the same, okay? Who says I totally gotcha? Let's see. Okay, great. All right, the graph of a function has one or no y-intercepts, okay? Do me a favor and just sketch a little xy axis right here. And then I want you to put 2 y-intercepts on that graph, okay? A function cannot have those 2 dots on it. Can't have 2 y-intercepts. Someone shout out why. Tell me why. I'm not going to tell you. It doesn't pass the vertical line test. Good. The x's repeat. Therefore, it's not a what? Come on, everybody. It's not a function anymore. Good. So you can't have 2. okay? To find a y-intercept, you're going to let x be a 0, okay? Everybody go 0, comma, some number. That's what a y-intercept looks like. You must write it as an ordered pair, okay? And a function can have a whole bunch of x-intercepts. So look at all these dots. Those green dots, it can have, you know, an infinite number of x-intercepts, and it's still a function, okay? To find the x-intercept, you're going to let y be a 0. So everybody put a 0 in the second location, put a number symbol in the first, and that's what an x-intercept is going to look like, okay? Okay, everybody look at this graph right here. Question, so they give me a graph, and then they ask me to find f of -3. Everybody draw an arrow right there to that -3. And you tell me, is that -3 an x value, everybody, or is it a y value? X. It's an x. So everybody write that in, x value. Now, let's look at the graph. Go to an x value of -3. You don't have to mark that on your graph. Just, you know, kind of look at mine. On all those points on that yellow line, x is a -3. Move to the point that's on my graph. Okay, what's that ordered pair? That's -3, -3. So the question on A, they're saying if x is a -3, finish the question. Don't answer the question, but finish it. If x is a -3, then what, guys? What is y? What's the answer to the question? -3. So everybody put equals -3, and that's how you're supposed to write that answer. Okay, let's do the next one. F of 2. So now we are looking right here, guys. We're looking at an x value of 2. What's that ordered pair on the graph? That would be 2, 0. Everybody in the room, tell me the answer to the question. I can't hear you. Tell me again. Everyone should be answering. 0, right? So everybody go equals 0. That's how you write it. Okay? All right. For what x values is the function equal to 0? Okay, so someone describe where on that graph the function is equal to 0. Can you tell me?
Where the graph like crosses the x.
You're exactly right. You're perfectly right, honey. Okay, so it's right here. I'll do them in red. It's right here, and right there. Now read the question. You guys, you have to be so careful in here on how you write the answer, and you have to read the question. For what x values? So everybody write x equals, and then you list those x values, which are -2, 0, and 2. You would not write those as ordered pairs because they asked you for what x values. Okay, now read the next question. Find the x-intercepts. Well, those 3 dots are the x-intercepts, but I'm not going to write x equals. What am I going to write, everybody? Ordered pairs. You're exactly right. So those values are still correct, but I have to write those as -2, 0, 0, 0, and 2, 0, like that. Okay? Who says I'm totally good? So far, so good. Give me some feedback. Okay, wonderful. Finish my sentence here, guys. Look at question D. If 0, 0 is an x-intercept, then I know it's a y-intercept. And can I have more than one y-intercept if that's a function? No. I can't. So literally, that's the answer. I didn't even look at the graph. And I know that that's going to be the answer. Now, if you look at the graph, which of course you're going to want to do, look at the x-intercepts. Well, I listed it at 0, 0. Okay? Find the domain. Okay, here's what I want you to do. I want everybody in the room to put everything down, and I want us to just kind of talk about this right here. Okay, so look, hook those together, and I want you to write down the words small to large. Okay, small to large, and then I want you to watch. Okay, everybody just look forward, kick back, and here we go. Okay, domain is x, right? The x-axis goes this way. Where are the x values small? To the right or to the left?
Left.
Talk to me.
Left.
To the left, right? These are the negatives. Now look what I'm going to do. I'm going to take that x-axis and I'm going to make my line perpendicular. So this is my testing line. If I'm testing domain, the testing line is perpendicular to the x, so it's like that. This is my graph. Look, here, 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 stop. So if I'm over here at the left, you guys tell me, do any of these x values that I'm talking about right here, do any of these touch my graph? Talk to me, everybody. They don't touch it, right? What's the first one that's going to touch it? You guys tell me. A -3. We're talking about x, so you listed as -3. So everybody write down the -3. And now I want you to answer me out loud. How do I close my -3? Why with the bracket? Because it actually touches it, right? Now, you guys are just going to shout out. Every person in this room is involved and paying attention. You're just going to shout out a quick yes or no when I ask you all these things, and I'm going to go fast. Does that graph touch an x value of -2?
Yes.
Yes or no? Yes. -1, guys?
Yes.
Yes. 0.
Yes.
1.
Yes.
2.
Yes.
3.
Yes.
4.
Yes.
5.
No.
4 is a yes, 5 is a no. So do I back it up to a 4 and make it a bracket? Is that what I do?
No.
Why not? What's wrong with that? You're in between, right? You're not counting any of those things. So you can't say 4 with a bracket. You have to say 5 with a tell me. Parentheses. Okay, write that down. Now we're going to do range. I really want you to just look forward. Okay? Range is y. Your testing line is going to be, first of all, where are the y values small? High or low?
Low.
Low. So I'm going to start low. Your testing line is perpendicular. We're going to start low. Do any of these y values that I'm showing you right here touch my graph? No. What's the first one that touches it? -3. Does it touch it? Yes. So you go -3, close with it, talk to me. A bracket. Now shout out yes or no, okay? How about a -2?
Yes.
-1.
Yes.
0.
Yes.
1.
Yes.
2.
Yes.
3.
Yes.
I got some yeses and I got some nos. If this graph touches a y value of 3 anywhere, then the answer is yes. Does it touch it anywhere? Yes, it does. It touches it here. That's the ordered pair -1, 3. And it touches it in all those places. Sure, it doesn't touch there. Who cares? Because it only has to touch once, and it's touching in a lot of places. So it's going to be 3 close with a tell me. Bracket is correct. I want to ask you one more question. Right here, in between that, right there, that horizontal line, this is important. How many points are on that segment? Can you tell me that? How many points are there? Nobody knows. What did you say?
Infinite.
You're right. It's infinite. Because no matter what point I have and what point I have, there's always going to be a point right in between. And you can keep cutting it, and it will never stop. There are an infinite number of points here. So those of you who said no, everybody makes mistakes. We're all going to make mistakes. For those of you who said no, it doesn't touch a 3. It actually touches a 3 in an infinite number of places. Okay? Who says I understand that? Okay. Somebody's hand went up. Whose hand?
I was just
Okay.
gonna ask, is that just because if there's a closed circle and an open circle, the closed one overrides the open one?
Yeah, I mean, the question is, does it ever touch a 3? So even if it doesn't touch it in one place, if it touches it somewhere, still touches it. Okay, good. Okay, let's move on, you guys, okay? Okay, so we are here, okay? Question 3A, find the domain and find the range. Okay, so let's do part A on question A. Now, if you guys participate and you start shouting these answers out, then we can move it along if you understand what we're doing, okay? Okay, so here we go. Look at the graph on the left. Domain is X. Do I start from the left or do I start from the right? The left, because it's small. If I'm clear over at that wall and I go up or down, am I going to touch that graph? Yes or no? Not getting a lot of answers.
Yes.
This go right here, does it stop right here?
No.
No, it goes on and on and on and on. So if my vertical line is clear over there at the wall, now tell me, is it going to touch the graph?
Yes.
Yes. Where's it going to touch it? Down there, right? Down. Okay, so negative infinity, close with it, tell me, with a parenthesis. all the way to, talk to me,
Negative
negative 2, close with a, tell me,
bracket.
bracket. Okay, is that everything? No, there's more. So what should I put now? I'm going to put a U. Okay, am I going to put a U? Yes, I am going to put a U. Okay, so it's going to be a negative infinity to a negative 2, close with a bracket, and then a U. And where does it pick up at again? Picks up at a 2 with a what? Bracket or parenthesis? Bracket. How far does it go? Forever. Infinity. Okay? Okay, that's a domain. So everybody go domain colon, and now let's do range. Range is Y. Now let's answer, okay? Start small. Make your line perpendicular to the y-axis. How far down is that graph going to go? Forever, right? So it's negative infinity. How high up does the graph go? To a 0, close with a, tell me, with a bracket. And that's it, okay? Question B. State the intercepts. I need you to know that if you ever have a question that says state the intercepts, you have to differentiate between x-intercepts and y-intercepts. So I want you to go, here are the x's and here are the y's. Even if it's none, you still have to list them and then say the word none, okay? Look at the graph. This is an x-intercept. Do you write it as x equals negative 2? What do? Must be an ordered pair. So it's negative 2, 0 and positive 2, 0. What is the y-intercept? That is none. So should I leave it blank? If you leave it blank, I don't know that you know that there isn't one. You have to communicate. For all I know, you skipped it, right? So write in the word none, okay? Part C, label the symmetry. Guys, look, here's half the graph. What do I have to fold that across to lie on top of the other half? The y-axis. Good. That's it. Okay, let's do question B. Part A, find the domain and find the range. Now you look at the graph. Domain is x. Start at the left. Move to the right. Is the domain everything? Tell me. It is not everything. It's everything except, tell me. 0. Good. So we're going to say x cannot be 0. Why is it x can't be 0? Guys, look right here. It never touches a 0. It's an asymptote is what that is, okay? Let's do range. Range is y. Start low. Move up. Shout out the range, everybody. Y cannot be equal to 0. Okay? Who says, I totally get that? Give me feedback. I need your hand up if you understand so I can gauge. Okay, good. Okay, question B is name the intercept. So I literally need you to write x-intercept, and I literally need you to write y-intercept, and if you don't, you will not get credit for the problem. Okay? Everybody in the room tell me, what is the x-intercept or intercepts? None. Talk to me about y. None. Same thing, none. Do you really have to write those? Yes. Symmetry. Take half the graph, fold it across the x. It is not x-axis symmetry. Take that same half the graph and fold it across the y. It is not y-axis symmetry because I'm not on top of the other half. If I take that pink and fold it then across the x, now I've got it. What's the answer? Origin is correct. Good. You have to go x and y in any order. Okay? All right. Question 4, and then we're done. This is a really quick lesson, and then we've got lots of things to talk about. Okay? Okay, consider the function. So I'm just going to tell you guys, will you listen? I think this will be, you'll see this question on things. So I would do some stars. You know, anybody that was in my 1010 class, you know how I went through and had you highlight the things that I felt like would be on the midterm? We're going to do that soon because I feel like the sooner we do that, the better. Don't you guys agree? Okay. It's just I have an hour long to teach you all the things I need to, which is insane. So that's why we haven't done a lot. Okay. Is the point 1, 2 on the graph? Okay. So what you're going to do is you're going to let x be 1. And then you're going to plug in the 1 and see if you get a, tell me, see if you get a 2. So everybody write f of 1 equals 1 plus 1 over 1 plus 2. 1 plus 1 is 2. 2 plus 1 is 3. So that means the ordered pair 1, 2/3 is on the graph. So is the point 1, 2 on the graph? Why not? If it was, I like how you said that. She said if it was when you plugged in a 1, then you would get a 2. You're exactly right. But I want someone to say another explanation.
It wouldn't be a function.
It wouldn't be a function. You got it, girl. Because 1, 2 and 1, 2/3, you can't have them both. And I know 1, 2/3 is for sure, right? So the correct answer is no. Okay, if x is 2, what is the value of f of x? It's the same problem. It's the same thing, guys. So everybody just go f of 2 equals 2 plus 1 over 2 plus 2. 2 plus 1 is a 3. 2 plus 2 is a 4. So the value of f of x is 3/4, and you're done with the first question. That's all you do. Then the next question said, what point? What it's going to say, I really should edit this. Say resulting point. What is the resulting point? Well, some people will do like this. Some people will go 0, 2. Well, 0, 2 is a point on that graph, or 0, 1/2, pardon me. But it's not the resulting point. So the resulting point is when x is 2, y is 3/4. So there's your second answer. So be careful. Okay? Okay, question C. If f of x is 2, what is x? You guys look at that original equation. All you're going to do is take that f of x and make it a 2. Because that's what they're saying. F of x is 2. So everybody go 2 equals x plus 1 over x plus 2. What's the easiest way to solve this? 2 words is what I want coming out of your mouth. Cross multiplies, exactly right. Put a 1 underneath the 2, cross multiply and distribute, and you get 2x plus 4 equals x plus 1. Pull the 1 over, pull the x over, it becomes a negative. So 2x minus 1x is x. Pull the 4 over to the right and it becomes a negative, and you get x equals -3. Read the question. What is the resulting point? Well, the resulting point is when x is a -3, then y is 2, like that. Hey, here's something I need you to know. That sometimes the textbook doesn't fully align with how we do things in here. So if they just know that they have to say the word point for you to write it as a point. Let's just leave it there like that. Okay? Okay, find the domain of the graph. You guys, this was from lesson number 2. Okay? Remember, if you have a fraction, the bottom of the fraction can't be a 0. Okay? So everybody write down x plus 2 cannot be 0. Therefore, x cannot be -2. That's literally your answer. Okay? Question E, what is the x-intercept? Well, the x-intercept is found by letting what equal what? Can you tell me that? Y be a 0. Good. So it's going to be an ordered pair. Put a 0 in the y location. And then look at that equation that I boxed. There's no y in there. There is a y. What is it? It's the f of x. Yeah, f of x is just a y. So you're just going to go 0 equals x plus 1 over x plus 2. Then you cross multiply and you get x plus 1 equals 0. Move your 1 over, x equals -1. There's your answer, -1, 0. Okay, one more and then we're done. Find the y-intercept. To find the y-intercept, you let what be what? Guys, talk to me. X be 0. Good. Okay, so this is going to be 0, something. You guys, I'm not even going to make you show work for this because look at the original equation. If x is a 0, this goes away and this goes away. And what do you have? 1 on the top and 2 on the bottom, which is 1/2. And that's your answer. That's it. Okay, we're done. How does that feel? Good? Okay. Do me a favor and just put everything down for just a second. And